How do I see?
Did it just turn back on? Just a second. Let's see if we can plug it out and in again.
Helen, is there anything on the remote?
Is there a way to open this so I can see it's coming next?
You're in?
Hmm?
Is there a way I can see it's coming next to this?
No, I'm here. So next is here. I don't know what that. Hey! Oh yeah? Okay, give me a sec then.
Go to the next one because people here.
No. Okay. Oh yeah.
Got it. I've lost the clicker thing, Magic. How did it back? Oh, stop it. Hey, how's it going, people? Can you all hear me at the back? Can you all hear me? Right, so my name is Passy, or William. I am a fresher student here at Aberystwyth University. And I want to talk to you about a project Ari and I are working on, which is simply called I Am You. Now, we were going to give you a fantastic technical demo and all that, but then we thought what's probably more interesting is the journey, because there's two sides to this journey. There's the technical journey of how you get there to build what we're trying to build. And then there's the sort of the behind the scenes journey, which a lot of people don't talk about. So to give you context, I'll tell you a bit about myself first. I am a serial entrepreneur. I've been working as an entrepreneur. A few years ago, I went on to Dragon's Den and got an absolute roasting from the dragons regarding one of my inventions, which was a solar-powered street litter bin. Concept was very simply a bin on the street with digital advertising, and this could be changed automatically from a central location. It actually went on to do quite well, and I managed to sell the company. After that, I started an event company called My City Venue. We ran for about 3 years, and then we eventually managed to get acquired by Secret Escapes. Google raised money and then bought us through Secret Escapes. And Secret Escapes acquired us. And then I decided, what am I going to do next? University. So came to university, and there I was sitting. I think I killed it. Okay, start. Space? I think the whole thing's frozen. Oops.
It's always fine.
It's always fine.
Oh, if we just. That's it.
Do you ever plug mine in?
If you click on the screen,
Wait, just. Yeah. There we are.
There we go.
Okay, now don't put that on there, and it will be all right.
Okay.
I can hold it for you. Come on.
I'll step on it. There you go. All right, so it all came down to one of my first induction days here in ABBA. We're sitting, I think it was in the physics main, being taught how to use the library systems. And we're watching this very, very fascinating video about how you go onto Primo system, book search, enter your details, and then you then have to go to one of these little charts over here, I think it's over there, and then wander the corridors to find the book in the library. I thought, there's got to be a better way. With this in mind, I thought maybe we could use technology to make things simpler. So I had an idea. Found an article and sketched this up. This is a sketch or an idea of what if we had a robot, which very simply, you walk up to it and ask it, I'm looking for X book or Y book. And then using very clever wizardry and mapping, which I will explain a lot better than I can, it will then take you to the location to where the book is exactly. This was just the idea. Obviously, being a student, I wasn't sure it was feasible. I didn't know it was feasible with the library systems. So I made a trip to the Visualization Center. There I spoke with the research team and the business people to find out what the IP or intellectual property sort of outlay was in the university. Then I went to find someone like Ariel. Actually, I'd already found Ariel to ask him if it was actually technically possible, because I'm actually a fresher still, and I've not really worked in air robotics yet, so I don't have the technical knowledge to be able to do so. But I'm good at working with people, at least I thought I could, and I found him and other people who hopefully be able to help us build this. So from the Visualization Center to the IS Information Services, to find out if it was actually possible to get full integration into their backend or the API system they use to search for books. The answer was yes, it was possible, and they were happy to support. So someone needed to pay for it, so I took a trip to London. London, knowing a few people, was able to get in touch with Microsoft, Cisco, the usual sort of people who throw money at things like this. So when I went there, I gave them a small pitch that this is the direction we're going. These are assistant robots. They're all still quite dumb, but it starts off like this. This is, I think this is called Personal Bot, an office assistant, where, what's it for the home? Office assistant, where it comes, where you, for instance, would ask it for appointments, it would set your appointments, it would remind you for things, the generic sort of stuff you'd expect from your Google, but this is a sort of embodied version of it. Jibo, as a version for the home, it would email you to send emails for you, take out orders for you, and Pepper is one in development at the moment. So I made this whole pitch of this is the direction things are going, and if we're slow, we're probably going to have a library robot anyway, but it'll be a Japanese import. So why don't you hopefully fund us so we could build Cube? Came back to ABBA again, managed to get the access we needed from IS, started doing the initial sort of design work to try to get the design right, all the CAD drawings, put a team of people together to help put this together, and then finally we're able to start looking at hardware. At that point, I'm going to hand you over to Ariel. Thank you very much.
Right. So before we sort of get to this robot, by the way, I'm Ariel. I've been to the September edition of the show and tell, had talk about my digital picture frame that's still actually running. It's now scheduled. It's all, well, fun games. So anyway, I met Will at a Physarc event watching the Blood Moon or something like that, and he came with some radical opinions that I had to sort of rebuttal. And we sort of went head to head, and until we arrived at a sort of middle ground for when the singularity might happen. So before coming here, I sort of dabbled a bit in robotics, but always in the form of something like this. So this is my little Frankenstein from a couple of years back, and I mean, it's an optimistic little thing, but it sort of met the wall quite literally after a while. And the thing about this project was that it sort of grew from humble beginnings to suddenly wanting to take over the world. And in that process, my code started to look more and more like spaghetti. And so when Will pitched the idea for Hue to me, I sort of knew I had to put on my business hat and say that, okay, we actually do need to sort of map out the scope and all of the stuff that I kind of made fun of in my previous talk, where we actually do a feasibility study and think about the sort of goals we have in mind, what milestones we want to achieve, and what do we actually need in terms of hardware and a development environment, what tools we want to use. And we sort of came to a conclusion because we really wanted to make use of existing tools and recognize the labor that people have put down before us. And so we really wanted to naturally, I mean, customize the wheel and find novel ways of using the wheel, but not reinvent it. So a framework seemed sort of important to find before we sort of just set out starting to put something together. And if you look for frameworks in the robotics sort of sphere, you'll soon come across ROS, the robotic operating system, often sort of depicted as a little awesome tool. I really thought that ROS was something that your DARPA cast would be utilizing, but that sort of regular people would have no chance of actually sort of learning and using in something like Hue. And so, thankfully, upon some reading, when I sort of delved into this, I found that that's not the case at all. You can use that on pretty much anything. In fact, Q's running on an ARM board, so you have a ROS sort of port over to the ARM platform, making also the Raspberry Pi available as a ROS node. And that's something we're going to come back to, because the thing is that ROS is pretty much used everywhere in industry, and that's sort of an example of that is the other day when we got a posting on AberCompSci Jobs, the group on Facebook, where Disney was looking for interns or work placements, people for work placements, and it turns out that one requirement is experience with ROS. And so sort of a little light bulb sort of lit in my head when I realized that this is actually something that's going to come in really handy. And the project that is Hue is very much a sort of, we aim to have this be how should I put it, a student-led project, and giving students the opportunity to work with something that is on the leading edge, if you will, is really valuable. So basically, ROS, for those of you unfamiliar, I say it's, well, depending on who you ask, it's a bird, it's a plane, it's a library set with sort of functionality for making robot applications. It's not really an operating system, as the name implies. It's more of a meta operating system. But the point of it is that it allows you to sort of encapsulate functionality and capabilities in logical nodes. And these nodes, like the camera wrapper, if you will, and the image processing node, can all sort of be on different actual hardware hosts. Controlled by a host master, they can provide or consume topics, or act as services for instance, an image display node, so you can pull for data. This is really nice because that means that we can actually sort of potentially change out hardware as we go. We don't need to know exactly what the perfect implementation for mapping the library floor is going to be beforehand. So that sort of brings us to the hardware implementation and the hardware we went for. So we went with a pretty sort of conventional starting point for a mobile robot needing to do simultaneous localization and mapping, meaning essentially find its way through a dynamic environment. And that is pretty much just a modified Kinect, if you will. It's not modified, it's a next generation Kinect from ASUS. With an NVIDIA Jetson development board. That's an ARM-driven board, as I said earlier, but it's got some CUDA cores able to do GPU acceleration if you need that. We also went with the Kabuki base. That's pretty similar to what you find in some of your robotic vacuum cleaners. It's a really nice base to start off with, because it's got battery and power management and all that jazz that sort of lets you get up and driving really fast. So it's a stepping stone in this case in more ways than one, because this sort of trinity allows us to use a set of or ROS project called Turtlebot, and that takes care of some of the pathfinding issues involved with sound mapping, and sort of allows us to again build sort of stand on the shoulders of giants for the initial implementation, where we can say, okay, I can modify this node to allow me to actually navigate this room here, and then I can sort of use that as a basis for actually inputting coordinates from something that we write. And of course, when we want to or if we feel the need to change out the hardware, if we need extra capabilities, that's fairly easily implemented. So again, it's great for getting up and running, but the real power here is that we can take out any of the sort of components and replace them with better components as we go along. This is going to be important, of course, for instance, getting a base that's more sort of suited to the environment of a library, meaning silent, robust, able to drive on carpet floors. So sort of back to what we're actually trying to do. Part of this is using the Primo API that the university has to actually allow you to sort of use Hue as a front end for Primo, meaning that if we use natural language processing on the front end, we get search strings that we feed into Primo. We get back a set of results. The user can pick the favorite or the correct result that is connected or linked to a class code. Now, I don't know enough about class codes. I don't really want to know about class codes, to be honest, but part of what we have to do is then correlate a range of class codes in sort of realistic terms. The library doesn't actually know where each and every book is. It knows the sort of circa location for the book, and that is why we need to sort of resolve a range of class codes into an XY coordinate, meaning for the first milestone, at least, the end of an aisle. So this thing will get you to the right area for the first milestone. That's sort of our goal. And as I've sort of dipped into the user interaction we hope for is voice-based, in addition to having a touch panel available for refining queries and well, all that, providing visual feedback. So, I mean, that's pretty much an intro to sort of the first part of the journey. We've spent a lot of time trying not to fall into the sort of or get into the pitfalls of process implementations where you sort of both try and enter into a new field, meaning robotics, and also try and sort of develop a product. Usually you want extensive experience before you even try and provide something that's going to be deployed on a library floor, interacting with real users. But in this case, we've sort of really given it an effort to where we now have a working hardware implementation of the base functionality that I can go and write a script to query the Google API for voice search and actually have that give me a search string that I can use as a command to send it to coordinate XY. And that's sort of a good step in the right direction. And right now we are looking forward to getting new people on board. More eyes on the problem is always a good thing. And we want to actually make a real student project out of this. And so there is one more slide, and that's sort of an artist's rendition of one way this could all look. And so with that, I'm going to hand it back over to you.
Thank you. And so that was our journey with you. And so what it simply shows, it's not just the technical side, there's the sort of groundwork as well, which is what a lot of us forget, that it's quite hard having to get, for instance, IS to approve you and all that other stuff that we had to do at the beginning. But this is where we are, and we'll gladly take any questions. Thank you.
Thank you. Good.
Okay.
Maybe actually, yeah, you'll change it. Right?
If I know how to change it back.
I believe in you. Excellent. Cheers. Grab this.
Mine's the computer that's on the floor. Yeah.
It's just a Mac.
It's okay, my computer's cracked. Oh, what is it doing? My computer's probably crashed. Colin, have you got a memory stick with your?
Yeah.
Yeah. Ariel, can we borrow your laptop?
Is it not staying on?
My computer's crashed.
No. Well, it is a Mac after all.
What do you mean it's a
Sorry for the technical issues.
Sorry, just to be anti-Mac move.
Is it on the internet? I do need to be online for this.
It's online for the most part.
Sorry, thank
Should be
you.
good. I'm just gonna actually
Dan,
try.
Dan, are you coming in? Yeah.
Is it dead?